Hi, everyone. Thanks for coming out for National Museum of Industrial History's virtual museum. Today, we're joined again by our historian, Mike Pierce. He's going to be talking to you about Slate. Mike has actually been with the museum for about 17 years and has done a lot with the museum in regards to our collection and how it's interpreted. So if you've been to the museum, you know the great kind of things that we have. And obviously, we're not able to be in the museum right now. So if you're able to help us, there's a couple different ways that you can do that. We're going to post a link down in the comments in a little bit, where you can head to our website at noih.org. And if you're watching this talk today, you know that you're watching this talk for free. And we have a lot of other ones coming up, including right after this, we're announcing a new one for Memorial Day. We're going to be talking about Bethlehem Steel and their role in World War I. And we have a lot of other talks, including Factory LLC, which is a great new company in Bethlehem. They'll be joining us, I believe, next Wednesday. That'll be posted tomorrow. And we have a ton of different content coming up. If you have kids, we have a lot of new youth program that we're launching. So please head to our website, noih.org, and check out our Facebook page here. Stay tuned. And again, if you're able to help us, please consider doing so by either purchasing a museum membership, giving us a donation, or if you're using Amazon to order things while you're stuck at home, you can use Amazon Smile, which also benefits the museum. But again, thanks everyone for joining us out there. And without further ado, I'm going to pass it over to Mike.
Thank you for having me, Glenn. I'm going to begin a screen share so I can show you my slideshow. Hopefully this will come up momentarily. It says host disabled attendee screen sharing, so I think you need to re-enable it, Glenn.
1 second.
Sorry about that. But in the meantime, as you work on that, I want to say that this is a quick look into the slate industry. It by no means is comprehensive. We could spend hours or days talking about all the nuances and details of this, but hopefully it'll give you a good basic overview of what goes into the industry. And normally when we do these presentations at the museum, we actually have a hands-on component where people can actually come and work a block of slate, split it, cut it, and actually take something home with them. And my technology doesn't really work with video right now. So again, the presentation is not what it should be, but I think it'll still be worthwhile to watch and get an idea of what goes on in these quarries.
Give me 1 second, technical difficulty.
That's okay, Glenn. This is probably a good time to say thank you to all the people that have been helping me over the years with the various quarry projects I've been involved with. The Dally Slate Company, Penn Big Bed Slate Company, Capizzola Brothers, and a lot of workers. Some of them are with us. Some of them, like Andrew Polo, have passed away. Local historical societies like the Slatefeld Heritage Center. They've all been fantastic to work with, and we look forward to many more years of sharing history between all of our organizations.
All right, Mike, I think you should be able to go ahead.
Excellent. So you should be seeing my slideshow momentarily. We're going to be starting off with a picture of a pile of the waste slate. But just like archaeologists study the remains of the past by digging it up, we can actually go to the quarries today and look at what's lying on the ground and start piecing together a story. So what you see here are the remains of some old roofs. Slate is natural material, so it's not toxic. You can dump it back at the quarry where it came from, and it's clean fill. So when you look at some of the slate that's been coming back used after maybe 100 years on a roof, it really starts telling you that slate is a stone that has a lot of different characteristics, and saying you want a slate roof is something that has a lot of interpretation to it. One of the things we've noticed locally when people say, oh, I want to get a slate roof for my house, depending on what roofer you use, you might end up getting slate from Portugal or who knows where, because people just assume that slate is slate, but that's really far from the truth. So this image here, if you look at it, you can see that there's all sorts of different colors. You see gray slate, black slate, depending on how your eyes see things, maybe a green slate in there, and purple slate. So the purple slate actually came from Vermont. Purple and green slates are mined up there. Dark black slate might have come from Monson, Maine. Slate that's black but has a lot of sparkle to it might have come from Virginia. Slate that's a really silvery gray was probably imported from India. And slate that's a bluish gray was probably made right here in Pennsylvania in the slate belt. So this is a map that was created by the University of Pennsylvania that shows all of the slate quarries that we know of in eastern Pennsylvania. The area in kind of a yellowish tone is Northampton County. To the left of that in the lighter grayish tone is Lehigh County. And just in the lower left-hand corner is Berks County. And you can see literally hundreds of slate quarries spanning these areas. So the slate industry got started in the United States in 1734 in Peach Bottom, Pennsylvania. That's down near the Maryland line. They had a small slate industry there that ran up into the mid-20th century. But the local quarries here in eastern Pennsylvania really got started around 1812. And there might have been something earlier going on that really didn't get recorded. But for practical purposes, our recorded history says 1812 in Slateford. Slateford is right along the Delaware River. You see those purple dots on the right-hand side near the top. That's the Slateford area, Slateford and Portland. So if you were coming from New York City, traveling west or traveling up the Delaware River, those were the quarries that you would have first encountered. Those quarries were discovered because water running down from the mountains eroded the dirt away and exposed slate in the stream beds of the waterways. You can actually still go to Delaware Water Gap National Recreation Area and follow one of those creeks up to a quarry that is open for visitors. It's barely recognizable as a quarry. It's very, very small, but it shows what that very early industry would have looked like. So in 1846, Robert Morris Jones came over and began the slate industry in Bangor. That's where you see those red dots over on the right-hand side. Then in 1850, Richard Chapman started Chapman's Quarries. Those are the quarries with the purple tags on them just north of Bath. Chapman came here from Cornwall, which is over in Great Britain. And that's where a lot of the early slaters came from, Cornwall, and then in the Bangor area, Wales. And then eventually later on, you had other ethnicities like the Italians coming over to work in the quarries. That's how the town of Roseto got its start. So we can see here, you really have two distinct bands. You have one band along the Blue Mountain, just to the south of the mountain, that extends all the way into Slateford, Slatedale, and Lehigh County. And slate exists in these bands, or as we know them, belts. That's why we have the slate belt of Pennsylvania. So you have your soft slate belt up along the mountain. Then you actually have a secondary belt of hard slate, which is what Chapman's quarries used to quarry. Then also in the Edelman and Belfast area, that was a harder vein of slate. If you're in the Bethlehem area and look up on the roofs, you'll notice that you see slates with a lot of striations in them. They almost look like zebra stripes. Those came from the hard vein slate quarries. Chapman's actually had an office in Bethlehem and supplied the roofing slate for Bethlehem Steel. So up until the 1970s or so, you would have seen acres and acres of these slate roofs on the Bethlehem Steel buildings, actually within sight of our museum. So most of the quarries in the area were open pits, but there were a handful that took a more European approach. And again, there are, of course, open pits in Europe too, but there were a very small number that were actually underground tunnels. So this is an important map to look at when you look at the industrialization of the slate industry. This is a real, basically follow the stone and see where it takes you approach. You have an entrance, you can see by the dotted line. You came in, walked around what was eventually a gob pile of waste slate. And waste slate's going to be a huge issue as we move forward in this presentation. The question always becomes, what do you do with this stuff? Then they followed the vein and eventually noticed it started dipping. That's why you have the Stalker area on the left that's flooded with water. Water is another huge problem with the slate industry and mining in general. So when you go into an underground slate cavern, you can see that the slate was quarried out by hand, blasted, and then you got that big pile of rock. The question is, what do you do with all this stuff? You have to haul it out somehow, or in the case of the underground quarries, just like the coal mines, you pile it up inside wherever you can, use it for roof support, just get it out of your way and have enough room for your production to follow through. But those were really the exception rather than the rule in this area. This is an image of Chapman's quarries, located just north of Bath. They were really a pioneering quarry in the area from a technological perspective, because when you look at these quarries, they could go hundreds, in some cases, depending on who you read, even over 1,000 feet deep. So you got to figure out, how do you get all the slate out of the ground? And in 1869, Richard Chapman came up with the idea of an aerial cableway to actually transport the slate out of these holes. And once you had a technological means of hauling the slate from great depths, you could really start expanding this. This, combined with the railroad access that was already developing for the anthracite coal in the area, meant that this was really becoming a hotbed of industrial activity. So we're going to narrow our focus down to two regions, Bangor and Penargil. This is the Bangor area, an aerial view looking over the quarries. And one thing I want you to pay attention to is how the quarries lay out, again, in that line, like a belt. And also, you can almost see the bottom of these quarries. You can see various ledges. That's because the slate in Bangor is defined by its ribbons. Ribbons is the carbonaceous material in between the slate. Slate is really volcanic ash or mud that was deposited in our area about 500 million years ago on the seafloor. And then that sedimentary rock was eventually metamorphosized, became metamorphic rock, of course, and tilted. So depending on how it tilted, that defined what the beds look like. Because you would have a nice, big, thick bed of slate that's very pure, made from silt, and you would have a carbonaceous layer, maybe a forest rotted away and decayed and mixing a lot of that plant matter, and that would be a separate layer. And that's really not the best layer that you want to have on your roof. Something like that might last 50 years and then fall apart. Inside it's fine, but on a roof, which was what a lot of slate was and still is used for, it's not the best material. So you want to cut out those ribbons. In Penargil, those ribbons existed vertically almost. So those quarries tended to be thinner but deeper. And we can get a better sense of that by looking at this image, these upcoming images here. This shows a typical Penargil quarry. You can see those bands in black that start curving. That's the way that the slate bedding dips. So between those bedding points, and there's many more in between that are really not visible in the picture, but these give you a good idea of how the slate kind of takes a curve to it to the right, then to the left, and after that it almost goes straight down, but kind of leans into the left, and leaning into the left is corresponding to leaning in towards the Blue Mountain. But the big deal about this is the Penargil quarries were relatively straight up and down. So if you started following a bed at the surface, you could follow it, it would meander a bit, but you could basically dig your hole straight up and down. Whereas in Bangor, if you wanted to follow your bed of slate and work that good slate that's in between those ribbons, which is the darker, more carbonaceous material that'll rot away faster, then you couldn't just dig straight down and follow the slate, because the slate veered to the left, as you can see in this image, and it would just keep on going. There were folds in some quarries, so there's always exceptions to the rules, but by and large, if you were in Bangor, you wanted to follow that ribbon, and you'd have a broader quarry, and once you got to the point where you were getting good slate out of it, you might just extend the quarry linearly. So you end up with quarries that were hundreds of feet wide in the Bangor region. We'll flip back to Penargil and see probably the most extreme example of following the slate straight down. This was at the Parsons Quarry. Right now, we can look at the text down here. This, I believe, was in the 20s, 500 feet deep. But this quarry went well over 900, depending on who you ask, even over 1,000 feet deep. And you can see that the slate wasn't exactly vertical. It dipped slightly. This quarry kept on following that depth so much that they actually went under the railroad tracks of the Delaware, Lackawanna, and Western Railroad and had to pay the railroad royalties for the slate that they mined under the right-of-way. But this eventually got so extreme that the bottom of the quarry collapsed over a weekend, filled the bottom of the quarry with waste slate and rock, and they retired it at that point in time. But for a while, that was the deepest quarry hole in the United States. So most of my work, I've studied the quarries. I did my master's thesis on them, worked around the Stevens-Jackson quarry in Penargil. So we have Richard Jackson Jr., and Henry Stevens. They were the founders of that quarry back in 1878. It was really in the late 1870s, 1880s that this industry really started picking up. You had easy rail access by then, you had plenty of markets, and you had an economy that was really ready for durable goods. Once you put a slate roof on a house, it would last, depending on the slate and the roofer and the environment it was in, easily over 100 years. There's one roof in Slatedale that was built in the 1840s. It was maintained as needed, and it's still in service today. So Stevens and Jackson started the Albion Quarry in Penargil. The story goes that Richard Jackson Jr. came over from Cornwall, was working at Chapman's Quarries, and decided to set out on his own. He was a rough and tumble guy in nature, had a wheelbarrow, and had a hankering that just south of the ball field, that's the current area in Penargil, there would be good slate. So he managed to get permission to start digging, tried to go for a bit to the bank for a loan. They turned him down. So he just started going at it by hand, struck some good slate. And what he found was the gray bed. This is probably the best bed of slate in the slate belt. It's named as a bed of a misnomer because all the slate here is gray. But when the slate is looked at up close, the slate that we mine today has kind of a bluish tint to it. But this slate, which is an olive green tint, looked grayer in comparison, so they called it the gray bed. And that was really what all the old-time quarry workers talk about as being the best in the region. He found this, and he was able to follow it and build a small quarry empire out of it at Stevens Jackson. So when he started out in the 1870s, we were doing all of this work by hand and with blasting powder. So if you look at this image of a typical slate belt quarry, probably in the 1890s, you can see that the walls on the left were blasted out, while the walls on the right were made by what was called a channeling machine. You can see one as we zoom in here. This is a machine that rode on a set of railroad tracks and used an air or steam operated set of chisels to chisel into the rock just like a stone carver would do and start freeing the stone up. It created a relatively smooth surface. It did fracture within a few inches of where it was channeled, but it was light years ahead of the blasting that was done before. And you can tell just by looking at the way the walls and ledges are on this quarry that they saved a lot of material when they got that channeler in there. So there was only one channeler left that we know of that survived in the slate belt. It was actually in a flooded quarry in Wind Gap. It was pulled out by Joe Beers in the 1980s, and we don't know what happened to it after that. So if anybody can find this thing, maybe it still survives somewhere. We'd love to know about it. But as far as our museum goes and trying to tell the story of the slate industry, this is the closest we have, which is pneumatic powered channeler built by Ingersoll Rand, probably over in eastern Pennsylvania, right along the Lehigh River. And this came from a sandstone quarry in Ohio. But again, it's one of the last examples of the technology. There's only a handful remaining in the country that we know of. We felt it was important to preserve and tell that story of technological innovation. The channeler worked for a number of decades in the quarries, but they realized that those channeling bits, which were basically chisels, wasted a good chunk of rock during the production. So what the technology of the slate quarrying industry evolved to in the 20s and 30s was towards core drills and wire saws. This is a core drill that still survives today. It has an electric motor on the left, a mast on the top, and the mast would raise these giant drill bits about 3 feet in diameter that were hollow on the inside, and they would spin around and create holes. Now, when they created the holes, they had a byproduct left over, which were these core discs. So if you drive around the slate belt today, you can occasionally find these on walkways or gardens. And these were what were left over after you did that core drilling. So the quarries didn't want anything to go to waste, so they actually found a market for these. So after you made these holes, which were about 14 feet deep, you would drill one, then you would space the other one out up to 50 feet away sometimes, and you would have to connect these holes. And that's what happened right here with the wire saw. Again, we could go into a whole lecture on different quarrying techniques in the wire saw, but what it boils down to is you have very thin wire. I'm going to guess maybe 1/4 of an inch, just eyeballing it, with 2 or 3 strands. And those strands would actually pick up sand right before it went into those holes, right after it went into those holes. It would enter in one hole, and this wire strand would be driven across to the second hole. They're actually metal posts made of wide flange beams that had wheels attached that would guide the rope up and down, spanning those holes, and it would create this very narrow cut. And by dropping sand and water onto that wire, the water would help carry the sand into the wire, into those little grooves, and the sand would actually do the cutting. So you can see in the lower left-hand image here, I'll try to zoom in on this. You had these 4 holes. It's 2 on the left and 2 in the middle, but the middle one is up at the top. So this is actually a really curious arrangement. So this is we're literally playing a game of connect the dots with this wire and how they cut these holes. But the bottom line is that by connecting these holes with the wire and sawing down to the bottom of them, they could have a very, very thin cut that wasted a minimum amount of material. And once you had 4 sides cut, you could go in with a wedge and start driving the slate out of the hole. Slate has a natural cleavage pattern to it, so you could split it basically any thickness you want. Sorry, we'll try this again. So this is what it looks like down inside one of those holes. This is what they call a drift. And you can see that they have these wedges stuck into the slate about 1 inch or 2 apart. Sorry, 1 or 2 feet apart, I mean. And a typical block size today would maybe be 12 inches, give or take a little bit. And you jam these wedges in, and because the slate splits naturally in a relatively flat pattern, you can drive those chisels in, and the crack will continue on several feet. And then they'll go either to the next saw line, or you can drill down and use what they call plug and feathers, like in traditional stone quarrying, to split the slate and limit your block size to something that's manageable. So after you've got that block split apart from the rest of the slate down there, you would tie a chain around it. The chain would be attached to a hook which descends from that aerial cableway. We'll go into more detail about that soon. And that would rise up to the surface. These blocks would typically weigh about 5 tons because that's the capacity of the cranes in the mills that service the blocks and cut it down to size afterwards. But these cableways were capable of lifting much heavier loads. I've heard 8 tons easily. I've heard 20, 24 tons based on descriptions of block sizes that have been brought up. Some of those might have been embellished a little bit because they were going by the memory of the workers who saw this stuff decades ago. But we know that 5 tons was only scratching the surface of what these were capable of. So today they've replaced the wire saws with these much more modern saws. So they're basically chain saws, but instead of a chain, they use a rubber blade that's impregnated with diamonds, industrial diamonds. So this arm goes down about 7 feet. It's on a track with little gears on it, so it advances very slowly, cuts away the slate, and then you move it over and you make your next cut, and you create a pattern on the quarry floor of how you want these blocks to lift out. And then you begin the process just like they did before with in the older days of chisels. They use the device called a stylus, which is like a wedge to block them up, and a lot of grunt labor to get these blocks freed. It's really like sculpting, but in reverse. So if you're at the bottom of the quarry, this is your view looking up. This is probably a few hundred to 500 feet deep, I'm guessing. You can see those aerial cableways rising over the top of you, and the block, which was probably about 5-7 feet wide and maybe 8 to 10 feet long, maybe even larger, depending on the block, rising up, and you can barely see it up there. When you're looking from the top down, people said the workers below look like ants. And if you got a quarry that was deep enough, the quarry would actually act like a smokestack does, because some of the smaller stacks act as telescopes, not with their magnification, but the fact that they narrow out the light, so you're only looking at a very small portion of the sky. So they said at some of the deeper quarries, you could actually look straight up and see the stars during the daytime. So we're going to talk more about how these blocks actually got out of the hole. So we have the aerial cableways here. This is, again, at Albion Quarry. These cableways remain stationary. So you could go forward and backwards with them, but you couldn't go side to side. So as the quarry went deeper, you could swing that block a little bit, that took a little bit further to get blocks. But you really had a limited range of about 50 feet or so. So once you wanted to extend your quarry beyond that, you really had to add a second cableway. So by the early 20th century, you literally had hundreds of cableways working these quarries in the slate belt. The cableways originally started out as a system operated by a single drum steam-powered hoisting engine. It would pull a carriage. You can see an illustration of the carriages up on top here. A carriage would ride on the wire rope. They called it the big rope because it was the largest one. It was about, I'd say, 2.5 inches in diameter, had a hemp core, and the hemp core allowed it to absorb oil, which allowed the oil to seep into the metal ropes made of wrought iron or later years steel and lubricate them. Because it's just like anything else. If it moves, it creates friction. So those ropes, which were continually bending, had to have an oil source in them. And in the early days, to add oil to the ropes, somebody would actually straddle that carriage and ride it all the way across the hole, painting oil onto it. What they do today is they put a can of oil on top, have a hole in the bottom, and they move it across mechanically without anybody riding on top and let the oil drip down to lubricate the rope, which is a much safer but less exciting way of doing it. So when they had a single drum hoisting engine, they still had to figure out how do you position this carriage above the hole so they can lift the block of slate out. So they had a second rope, which tied around the base of what they call the derrick, which you see on the left. It's kind of an A-frame looking device. And they put a brake on here. You can see a little brake lever off to the right, manually operated, barely visible. And that would hold the carriage steady as the load was raised up and down. And then the drum would continue pulling the load in to what they call the landing, which is the surface here, which you can see a little railroad track and cart. So trying to move, sorry about the slideshow. I might have to try a little trick to get to the next slide. But anyways, once you got to the surface, this is what you would see. This is an image of the North Bangor Quarry. Off on the left is the actual hole. On the left of the image that we actually see are those 1, 2, 3, 4, 5 very narrow A-frames. Hold the big rope up. And you can see the carriages as the little specks on the left. And then those cables, again, I apologize for the quality of this, but those cables are so small you just can't see them in the picture very well. But the cables extend to the right, to anchorage points, pass over the engine houses, where they have hoisting engines which wind the cable up. So this is a map, again, showing what we saw in that upper picture, a quarry on the top, hoist, and then railroad tracks that lead to all sorts of other destinations. But understand what really went on with those hoisting machines. We'll take a look at the cableway system and what it actually did. They used it for raising workers in and out of the quarries. They still use the same basic technology today. The only real difference is over the history 100 years ago is back then they didn't have safety railings around the boxes. They would use the rubbish boxes, which were open on one side and closed on 3 sides. And the workers would grab onto a chain and dry down. Normally this went smoothly, but occasionally you might have a hook that was unleashed because this was before they had safety lashes on the hooks. So there's a story of 2 quarry workers who ended up hanging on the chains for dear life as they made their way down into the hole. But they survived. And hopefully no quarry workers are listening to this now, but one of the tricks that the old timers used to play on visitors was if you got into a quarry basket like that, the rubbish bin, and they really wanted to upset you, they would actually lift you up in the air a little bit, spin that box, and by the time you were airborne and going down to the quarry hole with no way of getting out, you'd be ready to throw up. So they knew how to make it interesting, to say the least. So we talked about the derricks themselves. Many of them were A-frames, but those were replacements in later years fabricated by Bethlehem Steel over the original derricks, which were either A-frame and made of timbers or just plain straight wooden square poles. This is one that was 16 inches square across, a vertical mast, guy wires holding it down, and a huge block of slate being pulled up by it. Now, when we look at these, we can see the carriage, and behind it, you have all these little tiny ropes. We'll zoom in on these here. Those are what they call fall rope carriers. So when you move this carriage up and down that big rope, you still have your hoisting rope and that rope that's hauling the carriage back and forth, and those can get twisted up. So one of the big innovations in the field was these little wooden carriers that ride on wheels on a big rope, and they have chains connecting them, and they have a pulley set inside of them, and that allows those ropes that do the hoisting and pulling of the carriage to not get tangled up. So as the carriage goes out over the hole, these spacers, these fall rope carriers, eventually space out at a length determined by the chain attached to them, and help keep those ropes in line and keep them from twisting up. So these are what the cableways are actually anchored with. These are called deadmen, and that's their nickname because they're basically masses of dead weight. They have these huge, in early days, literally logs that were buried underneath them at the far end. And these act just like the anchorages on suspension bridges do. It's the same basic technology that the Brooklyn Bridge and all of those other ones use. These massive weights or anchorages hold the cable in place, keep it from moving. And the cable goes in between them, gets tied around that tree, or it could be a piece of steel. Or today they use big concrete anchors, because the problem with the trees was after several decades, they would eventually rot away and the cable would fall in. But the concrete is much more resilient. Now, if you were inside one of these booths that were operating the machinery for the hoisting engines, this is your view outside. You don't actually see the quarry hole. So you use the signals, you use a series of bell signals to communicate with the guys in the hole. There would actually be a second position known as a motioner who would sit in a shanty overlooking the quarry, and he would peer down and look at hand signals from the guys below him. And then he had a telegraph that he would telegraph commands to the engine house in. The engine house would have a bell that would ring, and he would listen to the bell code to know what he should do with that engine to lower the hook into just the right place in the quarry. Now, some of the engines were purchased from machinery providers like Exeter, who built machinery for the coal fields, or Holscheiser and Larsler, who became the Doylestown Agricultural Works. But a lot of them in the Slate Belt were actually built right here in Bangor, PA, by LaFleury Manufacturing. This is probably one of their most accurate ads. Not that they ever had any that were untruthful, but this is really the core of who they were. They were mining men who built machines for mining men. They were located literally a stone's throw away from the North Bangor Quarry. It was routine practice to walk visitors from the Floyd factory next door to the quarry, look down in the pit, visit the engine houses, see their products and service, and talk with the quarry operators about how they could improve their products. So they had dozens of different designs of hoist, but there was one predominant design that found use in the quarry after about the late 1880s and 90s, and that's the double drum hoist. If we remember that old incline system of cableways with that brake wheel, well, you could omit that brake wheel by adding a second drum to the hoist, putting your brakes on the hoist, and having all of your levers in one battery that the engineer operated, and therefore you had a self-contained unit that could operate the quarries without having an incline. It could actually be at level, and the carriage could go back and forth both directions by power of the engine. So the same basic technology is in use to this very day, except it's not steam, it's electric. So this is what the view inside one of the engine houses looked like. This is Andrew Polo. He passed away last year, but he was an engineer at the Slate quarries for decades. And you can see how he figured out where to control the hoist at. Most mines would have a dial with an arrow on it that looks a lot like a clock face that tells them where to go. But with the quarries, you really couldn't do that because you not only had to go up and down, you had to go forwards and backwards. So they rigged up a system of these nuts carried by strings to figure out where on the hoisting drum the rope would have to be when they were in a certain part of the quarry. And that served their purposes very well. You can also see some of the creature comforts of the engine house. They had what they called the couch in the back, which was really like a wooden chair that they could rest on. Here's another photograph of one. And these were and still are very common in the Slate quarry engine houses. This is Andrew again a few years ago at Rough and Tumble Engineers. Actually, he had to come back and operate one of those seam hoists under steam again. And this is a good engine to show how these things actually work, because in the process of moving this from the slate quarries, you can see how it was disassembled and reassembled on site. So you have your two steam engines, one in the front, one in the back, that drive a central crankshaft. The steam engines are reversible. They have Stephenson's valve gear, just like a typical 19th century steam locomotive would. A gear drive here that engages with gears on the drums. And you can see the drums here. And the drums revolve independently of the gears. So they actually have a clutch system. This is a Floyd clutch system here, where the drum travels on that central shaft, the same with the gears. And the drum is pushed up against a series of wooden friction pads that are lining the gear wheel. And by simply pushing this drum up against those friction pads, you create enough friction to actually hold several tons of weight. And that's how the loads are thrown in and out on those hoisting drums. So the drums can actually be pulled away and freewheel or pushed up against and run in time with those drums being spun by the engine. So over time, they found by the 1950s that it made more sense to operate these engines electrically from a financial standpoint. So as the boilers started giving out in the quarries, they started electrifying these things. So the last steam engine was finally retired in December of 1980. This is what a typical 1990s hoisting engine house would look like. You can see a motor on the right, rigged up to the old hoist. You just have the steam cylinders removed. They added some more creature comforts. They put a little bit more distance between the operator and the hoist, so you could actually have an area inside in the back that he could heat a little bit more securely than having the entire engine house warmed up. But this is the basic situation that you're with today, because these hoists, as Floyd has said in some of their other advertisements, dependability is their middle name, and these things are still going strong to this very day. So the hoist would actually deliver slate to the landing, and they would, in the early years, have a narrow gauge railway that took care of it. This is another one of those quarry mysteries. The railways were 33.5-inch gauge. We still don't know why that was picked. So if anybody has any theories, we'd love to hear it. But it was a very, very unusual gauge, but it seemed to be standard throughout the slate belt, though. So you can see here they have what they called quarry trucks, which were really narrow gauge railroad cars that swiveled and tilted, that carried the blocks to the mills. At the Stevens Jackson Quarry, they used Whitcomb locomotives built in 1925. They actually had a fleet of at least 4 of these things, I believe even more, at one point in time, that would carry the blocks to the mills. So at the mills, you would take the blocks of slate, side them off of the cars, and put them onto these saw beds. So this is a much older fashioned style saw. You can see the saw blade right in the middle here coming up. It's about midway through a cut in the stone. And after they cut the stone, or before they cut it, depending on how early in the time period that was, they would next have to get it down to a smaller size. So you can see this guy here operating an air chisel or an air drill, drilling away at the stone. And he's going to put probably plugs and feathers in there. Those are tapered feathers, and a plug which would be rammed in around those feathers. And that would split the stone apart as it's driven in, because it creates a wedge effect. And you can see where he already broke off one piece to the left, and he's getting ready to do one on the right there. And this is a great way of seeing the working conditions in some of those early quarries. All board and batten buildings. If you could sell your slate for a roof for somebody else, why would you have it as your quarry? So these little shanties got the wooden roofs. The more permanent structures, like the engine houses, did have slate roofs on them. But these shanties really weren't permanent. you can see from the railroad tracks around him and from other images, this created a lot of waste slate. So these shanties actually dumped the waste slate out the back, and when the slate got too high, like up to the floor level, that they couldn't have gravity feed the waste slate out anymore, they would actually jack these shanties up, put blocks underneath them, waste slate, of course, and keep on elevating these things so they could just let gravity do the work of disposing of the waste slate. So after you had your block cut to size, you would split it. It's literally taking a hammer and a very narrow chisel, going along in a nice straight line, and the block would naturally fracture wherever you put that chisel, assuming things went to plan. If you see on the left there, there's a bucket of water. They had to keep the slate wet because if the slate dried out, it became like concrete. It would set and it would not split straight. There's some slate in Europe that will split straight even after it dried out, but the slate in Penargil had to be quarried wet because, again, the quarries were subject to groundwater, and then worked wet, at least for the splitting stage of it. You could cut them to different sizes after they had dried out, but the splitting had to be done wet. So after the slate was split to size, you can see in this image, and again, I apologize for the quality. Normally these would be scanned, but when you're dealing with archival material that's locked up with the situation we're in now, we just use the research images we have. You can see in the guys on the right, we're splitting it. They took it to the worker on the left. He's doing what they call dressing the slate, and he has this big guillotine arm that goes up and down on a pivot, and that actually has an index on the back of it that corresponds to standard slate sizes. And you can take the irregular sizes from the guys who split it, and by cutting one side first and then squaring it up, you can actually make a nice rectangular piece of slate, and you can see it piled on those banks there. Now the guy at this machine was the puncher. So when slate is put on the roof, it's nailed on, and to get the nail holes, you typically don't drill them, you punch them. It's literally taking something that looks like a nail, and this foot-operated machine rams that nail-like punch down into the slate 2 at a time, because each slate gets 2 nail holes. And as it punches the slate, it automatically creates a countersink on the opposite side, which is where the nail head can rest. That's why the slate roofs can lay flat on the roof. Now, these guys in the early years were paid piece rate. And what you guys notice is lacking in this photograph, a bathroom. So they have them today, but back then, the workers were so intent on getting their piece rate, they didn't want to slow down for production. So if they had to use a production, they went on the shingle, flung the waste over the side of the waste slate dump, put the shingle back in the pile, and went back to work. So you can probably figure out where a certain expression might have originated from. So as the quarries went on, these operations eventually moved indoors. So this is a shot from the Valley Slate Company, one of their mills in Penargil, and it shows how the process really began to take on an assembly line-like production. The guys would split the slate, move it to the person who dressed it on this machine, and then what you really couldn't see in that earlier photograph were these railroad cars. They look like bookshelves in the earlier image, but the slate would get stacked on them and moved around the mill sites where you had to have different operations performed, or eventually the storage. So we'll go back to that image here. So those bookshelves here are not bookshelves, they're actually railroad cars. And we actually have one of those in the museum gift shop today we use as a bookshelf. But they're so utilitarian that it just makes sense to keep on using them for a similar purpose. So after they left the mill, they'd actually ride out on these trestles before they went out to the banks where they would be stored. But this trestle is very interesting because, again, it shows how industrial this process was. It goes over this long pit, and those machines that you saw inside, those dressing machines, which chopped off the slate from an irregular size to the rectangular size, all of those little pieces fell out down a chute and into this trench. And in the early days, they actually had a railroad car pulled by a hoist that would go up to the waste slate dumps and dump it out. And in later years, they would take an excavator, scoop out the slate, and dispose of it. So it was a very efficient process that was designed into these buildings. Now you had another set of buildings devoted to making structural slate. This is this is what one of those buildings, actually several of them, would have looked like. The big building in the back was this mill where they sawed the slate, and they could make structural products like stair treads, or in this particular company, blackboards. This was the largest blackboard manufacturer in the world in 1914, right there in Penargil at Stevens Jackson. So inside those mills, you have a steam engine, probably with I think a 14-inch diameter cylinder, 18-inch stroke, very similar in size to the red engine at the museum here, that would drive a system of line shafts with leather belts and pulleys, and they would drive machinery that would actually process the slate. Those of you familiar with metalworking would know that you can use a planer to shave away metal. Well, you can do the same thing with stone, but instead of having a really thin tool like a metalworking planer, you have a really wide tool, and it goes over the top of the irregular surface of the stone and shaves it down to a fairly smooth surface. And that bed goes back and forth, and you can move that blade up and down and side to side to eventually get a nice surface. You can improve that surface by putting the stone onto a rubbing bed. This has water and sand on it, and this is a giant 12 to 14 foot diameter disc that revolves. And you can see a block of slate on the right that is either getting ready to go on or has just come off of the bed. And that puts a nice sand rubbed finish that's equivalent to about 80 grit sandpaper on there. And that can be important because anybody who's walked on a slate sidewalk knows how slippery slate can be. So you have to have different surface finishes depending on the application of it. And this thing that looks like a weight that somebody would lift is actually a weight that's used to hold the slate down and keep it in place as the sand grinds away at it on that rubbing bed. The mills had a lot of other support pieces of machinery in there. This is a machine that's actually at the museum today. It's in storage, but we do bring it out for special exhibits. It's a wood lathe that the Quarry used for making their own wooden mallets. So what's important about the lathe is not just how economically it's constructed, but where it's located at. It's actually located in the rafters of the mill. So you had to climb a ladder to get to this thing. And then instead of having belts that go down from a line shaft, they went sideways. So they wasted no amount of space in this. You can see it hadn't been used in a long time by the time we found it, and the building's been torn down since. So we felt this was an important piece of history that we wanted to make sure survived. Now, the modern mills still use saws, except they have computer controls on them, digital readouts, but it's still the same basic technique of sawing the slate, getting it into smaller blocks. And from there, they still use hand tools to split the slate, and then some more modern machinery that can process it and smooth it out. But by and large, it's still a very, I don't want to say old-fashioned process, but in some ways it is, but in some ways that's very appropriate, because when you're dealing with a product that's 500 million years old, sometimes the older ways of working with it still are the best. Now, before we go, I realize we're running short on time. I'll just do a quick progression of the quarry here so you can see how it evolved over time. This is focusing on Stevens Jackson. Early years, about 10, 20 years after opening, you had 4 or 5 ropes, and you had your mill building down on the right. Then it expanded, and as it expanded, another company actually merged, not legally, but physically into the quarry. Keenan Structural Slate came in from the north and started operating. So you had 2 companies operating one giant quarry hole. Then in the 1930s, this is what it looked like. Stevens Jackson working on the east side. You can see those ledges that are nice and neat. And then you can see an older part of the quarry that they started filling in. Because again, waste slate has always been the problem. Where do you put it? In the early days, the quarries would actually buy up farms nearby and just dump the waste slate on the quarries. The smarter quarries bought up farms north or south of them that were not on the runs of slate. Because remember, these slate exist in belts. So if you want to expand your quarry, the last thing you want to do is build a dump to the left or right of it, because that means you have to get rid of that dump if you want to expand your quarry. So in the 1940s, there was a collapse. There's still a person, Joseph Heater, buried under it today. that ended operations on the east side of the quarry. So in 1948, they opened up a western extension, which you can see in the shadows here, and barely make out 3 ropes going over it. And this is a good time to point out that that quarry opened in 48, lasted until 1980. It was 700 to 800 feet deep or so. I don't have a firm number. But when you look at and start averaging out these quarries, you'll see that they go down about 30 feet a year. So if you're going to work in the quarries your entire career, you might see a quarry go down 700, 800, 900 feet and then start a new one. So we'll move on a little bit further. You'll see that by 1970s, you had only that quarry on the left operating. The rest of that giant pit had been used for fill. And after 1980, they didn't have a need to quarry it any further. The company had purchased other properties. And at that depth, they're really getting to the point where it makes more sense to start mining fresh. So today the quarry is filled in, but it's still used as a dump for the waste slate. That's why you don't see any new piles coming up, because it's dumped in the old quarries. And in some operations, it's also ground up and used as ground cover. So again, this is only a fraction of the story of Slate, but I think it's a very, very fascinating one. And we can go into much more detail on other parts of the operation at a future date. But for now, I think this is a good time to see if we have any questions. Glenn?
Thanks, Mike. I just checked. I don't think we have any questions. But if anybody has anything after they watch this later on, please feel free to ask them in the comments, and we'll do our best to answer your questions. And thanks again for everybody that joined the talk. Really appreciate everyone joining us. As I mentioned before, we have a lot of other great programming coming up. We have the Factory LLC, who will be joining us next Wednesday. And we also have John Smith from Lehigh University, who's going to be joining us Monday and talking about Bethlehem Steel's role in World War I. If you have any kids, we also have a lot of great kids programs going to be coming up. And one of those is online story time tomorrow. And then we have Quotes and Quests on Tuesday. And we have live virtual Tinker Time on Thursdays. So if you'd like to check out more about those programs, either stay tuned here on our Facebook page or head over to NMIH.org, which is our website, for more information. Thanks again, everyone. Thanks again, Mike.
Thank you, and look forward to next time.